this exploratory framework that I call contextual scaffolds. And what the framework hopes to accomplish is a universal, generalized framework for prompt engineering, which is a topic that is of great interest and continues to be and will likely continue to be of great interest going forward as people look for effective ways to interact with generative AI systems, in particular generative text like ChatGPT, or if you use Bard or any of the other models that might be out there. So just a quick recap. Really, this builds off of something we covered last week. So I'll give you some context on that to start. So prompt engineering, to the extent you're new to the concept, simply designing inputs for generative AI in a way that produces optimal outputs. In the case of generative text, and this does apply also to generative images as well, context is key, and a grasp of pragmatics is essential. Pragmatics being a subfield of linguistics that's concerned with how context contributes to meaning. My view is that the relevance of prompt engineering will wane over time. Interestingly, that's a view shared by Sam Altman at OpenAI. As these models get better at inferring context, then having to spend lots of effort coming up with a formulation for a prompt that yields a particular output or an expected output is likely to become less of a burden as these models become more capable in the future. Some examples of techniques, a concept called few-shot prompting. So this is where you would provide examples to the model to do what's called in-context learning right within the dialogue itself. Chain of thought, which is another very popular one underwritten by a paper, I believe from 2021, where you guide the model to think step by step in order to produce a specific outcome or a specific output. And then flattery, role assignment, another very popular type of technique where you ask the model to act like some kind of expert in an effort to generate the output that you're looking for. Act like a Pulitzer Prize winning author and help me write an article or a story. Those types of techniques are quite prevalent and in use a lot in terms of these models. Last week, we talked about this new technique category. I refrain from calling it novel because there's just so much activity in the space that it's hard to believe that no one else has really done this. But we asked the model effectively to behave like a program and simulate a program in an effort to produce the output that we're looking for, or the experience for that matter that we're looking for. In the case of a program, it's more experiential in nature. The technique lives probably somewhere between flattery, role assignment, and instruction based. And it's the premise of a couple of articles that were published in Towards Data Science that sort of poke at what this technique might be capable of. One of the articles digs into this further and provides a framework for program simulation where you either define many of the functions to few of the functions on one axis, and separately on the horizontal axis, you specify whether or not the model should configure the behavior autonomously, or whether you provide this very rich definition of the configuration and behavior. And then when you do that, you dimensionalize into these different buckets where you define many of the functions and the configuration, and that would lead to something we would call structured pre-configured, all the way to unstructured self-configuring, which is that blue dot, where the model, you simply specify the purpose of the program simulation, and you leave the model discretion and autonomy on defining the functions and configuration. If you're interested in digging in, there's a couple of articles, if you haven't seen them already, that go and discuss examples. And if you look at my LinkedIn, there's also a number of folks out in the community from different places, whether Microsoft or others, that are using this and coming up with their own approaches in terms of specifying program simulation type prompts. And this works best, just as a caveat, with ChatGPT 4. 3.5 starts to lose the ability to handle this type of context, and the open source models are very spotty. 4 is really the place you would want to employ a technique like this. Here's an example of a program simulation prompt. It's different from the one we presented last week. This was a mind mapping program simulation. It's actually published on LinkedIn. And as you can see, I've highlighted in red and underlined some of the key semantics and words that you want to specify to behave like a self-assembling program, whose purpose is to create mind maps for users. And then in this case, this is structured self-configuring. And because it's structured, we'll want to specify many of the functions. So as you see here, the first one is to create a new mind map. We might have a function to add a node, a function to enrich a node, and then we continue to delete a node, edit a node, etc. And the fascinating thing about the model is that one of the challenges with prompting and the usage of these models is you often have a difficult time recalling context from earlier in the prompt or content. And this sort of program simulation pushes the model into behaving in a way where that becomes more consistent. And I haven't tested it empirically, but that's something that we might look to do is to see if, in fact, this becomes a viable method for doing things that are notoriously more challenging within the context of these large language models. Finally, at the bottom here, your goal, it's always good to specify a goal for the model, is to run the remainder of the chat as a fully functioning program. And if you were to send this through in a prompt, you'll get something that looks like this. Because it's generative, and because, again, it's word by word, token by token, you're all likely to experience something different in the process. So that's one of the downsides of using a generative model for a purpose like this. But on the flip side, maybe there is no program for a mind map, nor do you want to purchase one, or maybe it's just a one-off task that you're trying to accomplish. And here's a quick prototype way to go about employing a technique in a programmatic manner using the generative abilities of a model like ChatGPT 4 to do something like a mind map. And if you were to continue with this, for example, you interact with the model by specifying the function in question. So here I would type 1, and it'll ask me to propose an idea or a problem to create the mind map around, and then it'll simulate the map and present the menu again, and you have this sort of interactive, much more intuitive approach to utilizing a generative text model than what OpenAI has provided on their interface, which is appropriate. I mean, they're a foundation model. It's supposed to be generalized. It's not supposed to have all these bells and whistles. It's really up to the users to come up with approaches like this that might alter the experience in a way that's more effective for what we're trying to do. So why does this work? It's really interesting that the generative model is capable of simulating a finite program state. You know, the menu is presented consistently throughout the dialogue and retrieved. The functions behave consistently throughout the dialogue if they're invoked multiple times throughout that interaction. A strange thing for a token by token, word by word chat model to do. So as I dwell further, I started digging into the world of linguistics and specifically focused on pragmatics, which, as I said earlier, is a branch of linguistics that examines how context shapes meaning interpretation. And it's different from semantics, which is the more well-known term from the linguistics perspective, which studies meaning in isolation, the dictionary definition, if you will, of a word, and how they then combine to form meanings in larger units like sentences, paragraphs, etc. An example of the distinction or the relevance of pragmatics: can you pass the salt? And if I were to say that to someone, I'm not asking that person if they are physically capable of passing the salt. And so if you take a moment and think about that phrase in that way, it could very well mean that. But we all know that what it in fact means in context is hand me the salt, which we would assume is within reach of the listener to be able to hand it to me. And so pragmatics is a very interesting field. There's not a ton of research or investigations that I came across that look at pragmatics within the context of large language models. But I think it's particularly relevant in thinking about why does a program simulation work. In particular, there's a couple of concepts in pragmatics that I think are particularly applicable. And the notion of implicature. So when we imply something without explicitly stating it, expecting our listener to infer the intended meaning. And if we were to just replace listener with large language model, it actually is somewhat applicable. This is a human dialogue concept, but we are speaking to our model in a sense. We're dialoguing with it. So this feels it feels like it's going to be relevant. The other concept, presupposition, assumptions or information that participants in a dialogue believe to be shared. And an example of this is when I would, for example, say the word dog, I don't separately need to tell the listener that dogs exist in time, they move through space, they eat. All right, those are all presuppositions, information that I, as the speaker, assume that a listener is going to know. And if whatever I'm saying about a dog happens to include those things or refer to those things, I don't explicitly state them because, again, it's information that I believe that the listener already knows about a dog, for example. Which brought me to this notion of a meaning aura, and it's a concept term that I made up. And the way I define it is every linguistic expression, be it a word, a novel, emits a meaning aura. And the meaning aura is a blend of implicit definitions, implicature, sentiment, connotation, and it can vary in density, complexity, and clarity. Back up a second and think about program simulation. When we say the word program and input that into a large language model, there's a tremendous amount of implicit definitions, maybe not so much sentiment in the case of a program, but definitely there's a rich semantic meaning aura associated with a program. And that's why when we put that into the model, having achieved these significant capabilities in modeling probabilities between words and contexts, the model then, if we ask it to behave like a program, in fact, attempts to do so with relatively high fidelity. With that sort of groundwork, we now move on to this notion of the contextual scaffolds. And so for any given prompt, you can likely boil it down into really two areas from a context perspective. Your expectational context, which encompasses your aspirations, intent, objectives, specifics of the situation. If personal context is relevant, it should be factored in. And then operational context, which you establish the operational parameters for the model or the generative AI model in terms of defining its roles, techniques, required external data, and the extent of its autonomy and discretion. And this model generalizes extremely well in the sense that it is likely something that can be applied in a wide variety of settings. If we just look at a prompt, and here's a visualized framework for this, that the prompt simply equals your expectational context scaffold plus your operational context scaffold. And very simply, expectational context is your objective and expectations. And the operational context is just how the model should operate. And it's a very simple formula, which could likely be very powerful then as you try to think about any given prompt that you're coming up with. Techniques like chain of thought, instruction-based, flattery, role assignment, you actually all fit in the operational context scaffold, right? None of those techniques speak about defining your expectational context within the technique. It's implied everyone should know that they should define their expectations in some explicit manner that's appropriate. But the techniques themselves that are very popular right now actually don't speak to that aspect whatsoever. And breaking them apart, I think, is relatively important, as we'll see in a second here. So case number one, let's say we know the expectational and operational context. So here's the draft of the first piece of a prompt. my expectational context, your goal. Now, this is again a prompt I'm loading into ChatGPT 4. Your goal is to help me analyze the banking industry and develop use cases for real-time machine learning combined with behavioral social science, right? This is near and dear to the heart of everyone in ecosystem AI, this combination of real-time machine learning and behavioral social science as being an intersection that's particularly important in helping organizations come up with very intelligent ways of dealing with their customers. So that's my expectations. And then as far as the model's operational context, you can see here is a very specific wording I've used. In an effort to maximize the fulfillment of my expectational context, behave from this point forward as a self-assembling program simulation. And then I give it quite a bit more context here. I tell it has autonomy and discretion. I really establish these operational parameters around how the model should behave in an effort to, again, maximize the fulfillment of my expectational context. It's an interesting way to author a prompt, but in some respects, I was curious to see if this would even work. Would the model get confused because of this sort of odd construction within how the was loaded and breaking it up in this manner? But true to form, ChatGPT 4 produced a program simulation. And again, there was the operational context specified discretion, autonomy. I didn't really give it much instruction. And so it free-formed what it thought might be appropriate, but again, within the framework of maximizing my expectational context. I am trying to develop use cases for machine learning combined with behavioral social science for the banking industry, right? And so actually provided a neat outline overview of the banking industry, introduction to real-time machine learning, potential use cases and for real-time machine learning and banking, et cetera. And if I, when I submitted 4, you can see at the bottom there, it says, please select an option, right? These were the use cases enumerated by the model, which all seem appropriate. Did it maximize the fulfillment of my expectational context? That's likely more of a subjective exercise, but nevertheless, these use cases do feel appropriate. Personalized banking experience, fraud detection, credit scoring, and there's quite a bit more context that the model produced, which if we have time, we might actually try to do more of an interactive session with ChatGPT, but I do want to make sure we leave some time for questions here. So interestingly, with this approach, what you can additionally do is, assuming your expectational context, what you want to try to accomplish, what your expectations are, what the output you're hoping to get from a model, but then solve for the operational context in question. So have the model produce the operational context or contexts that could be utilized for any given scenario. We use the same expectational context as before, but let's take a look at this operational context here, which is a little bit different. We're asking it to suggest at least 1, but no more than 5 operational contexts that it could employ. And in this case, I actually use some in-context learning. I give it examples. You might suggest behaving as a person, a team, a system. You might suggest the inclusion of external data. So actually do some in-context learning within this prompt itself. And then I ask it to rank order these operational contexts from optimal to least optimal, or most optimal to least optimal, and then provide a rationale as to why the model decided that was the ranking in question. And so we got back some operational contexts here. I've listed them enumerated by ChatGPT 4. That in an effort to maximize that expectational context of analyzing the banking industry to come up with those use cases, that it could in fact behave like an integrated research organization, a machine learning system with external data integration, et cetera, consultative entity, combination of organizations, a program, an entity, a system, all scenarios that from a meaning aura perspective, emit a tremendous amount of information right? When I say integrated research organization, there's likely a mental model of context that all of you and myself are coming up with as to what that might mean, and what that would convey in the sense of a real in a real life scenario, and what the model is trying to capture then by suggesting that as an appropriate operational context. And again, I've only listed here um, the one line descriptions, but the model did expand on these quite a bit, provided a rank, gave me a rationale. And if I were using this in a real life setting, you could tremendously useful. I hadn't thought of a number of different things. Provide sort of this ideation framework where you can extract insights and then iterate with the model to refine ideas and come up with solutions or outputs that sort of then very much meet your expectations or ideally exceed them. Which brings me to a notion that we're likely to explore further in the future in terms of optimizing contextual scaffolds, effectively solving for one or more optimal operational contexts given an expectational context. This is a lot of math. I'm not going to dig into it, but suffice it to say that there's likely multiple optimal operational contexts for any given expectational context. And using a more rigorous structured approach, we might think of how the model might help us arrive at this, but then also empirically test it and see, is this an area where we could use a framework like this to fine tune models, right? Using operational and expectational context. It's not an approach that we've seen in the wild in terms of coming up with a prompt completion data set. Using this framework of pragmatics to then optimize and fine tune. But it's something that, the investigation here and just this practical exercise and these scaffolds might suggest is something that we could potentially look into further. So here's the rest of the math. I'm not going to dig into it unless someone really wants to get into the math. Here are the links to the articles. They do follow a progression. The program simulation, new ChatGPT prompt engineering technique, program simulation was the first. From that, I extended out a framework for program simulation. And so the iteration now beyond that is, okay, why does that even work? Why does this type of an approach lead to this sort of very rich and fulfilling interaction with a model, which brought me to this latest one, which is this universal roadmap for prompt engineering contextual scaffolds, which was actually just published overnight, literally hot off the press, and hopefully something that everyone will find useful in their prompt engineering journeys. With that, love to take any questions or comments or anything that folks want to talk about with respect to this.
Go for it, RJ.
Yeah, go ahead.
Okay, thanks. So yeah, my question is, when I see that slide that you just raised there, why does it work? What pops into my head is, well, what did you do to make it work? Or what should a person do to make it work? And I think one thing a person has to do maybe is constantly have that framework instruction in the prompt repeatedly, either as a system level prompt or a custom instruction kind of prompt like they have in ChatGPT, where it's constantly in the background, even though you don't use it each time, it's automatically getting injected each time. So I was wondering if you could comment on that in terms of, do you have to constantly be repeating this prompt in some way, partially with each chat instance, with every time you hit the enter button kind of thing?
Yeah, that's a good question. Maybe what I'll do here is actually, let's pull up ChatGPT live and see, and hopefully that'll help.
Live demonstrations, Giuseppe. Good luck.
Yes. So hopefully everyone can see that. So here we go, right? My expectational context, right? This is what I in fact used. And in this case, this is the one where, let's see here. we asked for this more, we asked ChatGPT to provide the operational contexts. Actually, you know what, let's go with the one that's more, let's go with the program simulation one, because I think RJ, that better helps better illustrate what's happening here. So here's the program simulation. I simply, typed 4 in this case, right, which was correspondent to potential use cases, and it gave me all these use cases. So let's see if it comes back with the menu, right? To your question.
By the way, could you zoom in a little bit, because there's no way to magnify the screen with Google Meet, and so it's really hard to see the text. If you could somehow zoom in or make it much bigger so it has most of the screen, that it would show up on the video better too. Thanks.
Yeah, let's get rid of this. All right,
and you're not using custom instructions, right? There's no prompt going in at a custom instruction level.
No, in fact, and hopefully this doesn't give people nausea, but here was the prompt, right? And in this case, again, we asked it to behave like a self-assembling program simulation. And this is what it first provided. I interacted with it next by selecting one of the options from the menu, as I've been provided the option to do. Again, the completion from ChatGPT 4 now was option 4. It gave me all these potential use cases. And so that's where we are at this point. I'll ask it for the menu. And there you have it, right? So to answer your question, we didn't need to re-inject anything, nor was this specified in the custom instructions. One of the interesting things about the behavior of this interface that people aren't aware of is that this is stateless. So every time you send back, so when I said menu, it appended menu to the entirety of this dialogue and sent it back to the model, and now produced another completion. It's custom instructions are likely useful where the model will lose sight of its context within some very long dialogue that it's having. But in my experience, when it's asked to behave like a program, because of this notion of a meaning aura, this semantically, pragmatically rich meaning aura around the notion of a program, the model just really, that has such a dramatic influence on the context that the model is just capable of holding this state. One thing that we probably will look at is whether or not retrieval augmented generation, what they call RAG, is necessary in order to enforce that program state, if that's desirable or not. Even you could potentially look at retrieving the context of the program separately, and as you're describing, RJ, re-inject that back into the prompt as needed.
So can I ask now, when you use this simulated program that you've created here, does it eventually forget the menu and list the menu incorrectly after a certain amount of tries? I still am having a hard time understanding how you're getting it to be able to remember this.
The best way to describe it is I'm getting it to remember it by initially telling it to behave like a program. And a program, as we know, is supposed to behave consistently with a finite state. If there's a menu defined in the program, that should be persistent, and that's how the notion of a program very much is that it's all these functions that are predefined and behave in an expected manner when interacted with. As far as anything else, no. I mean, I've only tested it in my own experiences with this experimentation and using the technique for different things that I'm doing, and it surprisingly does not lose that menu. But to be certain of that, we'd have to really rigorously test it, come up with a testing framework to really press it, and then come up with some metrics around whether or not at some stage it loses the menu, whether that's because we've pushed too far into the dialogue from a token perspective, or there might be other conditions where the context becomes confusing, and the model just simply loses this grasp of its being asked to behave like a program. But the very
All right. Yeah. So if I could just, what I'm thinking is, I'm trying to guess why ChatGPT is capable of doing this. And what popped into my head is I'm thinking most likely it's because of the refined training that it got at a later point in time to follow instructions. So maybe somehow as part of that reinforcement of human learning or the instruct training that it got, maybe somehow that ingrained within it this kind of focus that you mentioned. But yeah, thanks for answering all these questions. I know they're tricky to answer because we don't really know what's in the black box. Thank you.
Yeah, no problem. I mean, yes, there's these enigmatic capabilities that are emergent, these emergent capabilities. And I'm not sure the folks at OpenAI would necessarily have a very clear answer for this, except what you're pointing at. And the corpus that it was pre-trained on, I'm sure had lots of context around what a program does. In fact, code, it was trained in a substantial way on computer code, these repositories. So it's maybe not surprising, even if it's enigmatic, we have a hard time explaining exactly why it might be capable of this. So the question is how to deal with personal information in the prompt. Is there any technique to mask or anonymize personal info? I would say that any personal identifiable information you should definitely pause, because it's now within the hands of OpenAI, and they've made all kinds of promises and assertions about what they do and do not do with the information. But we know that they use these prompt completion, these dialogues, in an effort to fine tune and train models. And so I think to the extent possible that you should just really avoid any personal identifiable information. But you can speak in the abstract, refer to a person as some person with these characteristics. You may come up with a fictitious name, so something like that, but definitely avoid any personal identifiable information being included within the prompt. That's, I think, just good advice no matter what. Let's see here. So for this method, how will it react if asked to actually create a software program compared to the output of the program simulation method? So I don't know if the prompts are quite meaty, so there's a lot there. One of the things that's included in them is an instruction to not produce computer code, because one of the challenges with this type of a prompt is that, again, context being so prevalent in these interactions, if you're not very specific, there can be a tendency for it to actually try to write a computer program. It might pick Python and launch into a code window where it starts to outline functions that would create a program, an actual computer program that could do the things you're asking it to do, which might be desirable. And lots of folks use ChatGPT 4 or Bard for coding in various languages like Python or JavaScript or whatever your language of choice is. Thanks, everyone. Really appreciate you tuning in, and hopefully there's something you can take away from this and put to use in your endeavors in using these models.